All right, good morning, everybody, and welcome to the WQA preparation course. This is a Moti-Vitality 15-week webinar series that hopefully will prepare you for a successful exam-taking experience. So 15 weeks of fun. I'm really excited because this is going to be awesome. I actually really do enjoy starting these classes and doing these classes and having an opportunity to serve you guys in this way. So let's get started right away. I want to first say thank you very much. You will find, those of you that have seen my presentations in the past and that those of you that will be observing them in the future, you'll see that I start every presentation that I do with a thank you, and I mean it sincerely. I do really appreciate the opportunity to serve you. It's always my goal every time I present to make sure that the information that I give to you is at least as valuable as the time that you're giving to me, and I really do appreciate it. Today, what we're going to talk about today to get started is class requirements. We're going to talk a little bit about the test, how to study, how to prepare. I'm going to share my desktop. We're going to log on to the link to the page so that you can see what we have up online and what it's going to look like. So we're going to talk a little bit about class requirements. Then we're going to go into some basic water characteristics. There's not going to be anything really super complicated in today's course. There's definitely going to be some interesting stuff, and there may be some stuff that that you haven't learned in a while or ever seen, and it comes from the book. But we're going to talk a little bit about water characteristics. We're going to go back to elementary school and talk about the hydrologic cycle. And then we're going to talk about different sources of water and where they come from, and that includes surface, ground, and cistern. A little bit about suspended solids versus dissolved solids. We're not going to get into that a whole lot until later in the course. Okay, but let's talk about course requirements and kind of what's going to happen over the next couple months. First off, this is normally a 15-week course. Now, we had a schedule conflict, and we delayed the beginning of the course, but we designed the course. There's a lot of you that are from some of the state associations, in particular EWQA, and so we tried to plan the course to where you would be able to take the course at one of the state associations in EWQA, so that the last class coincides directly with the time you would be taking the exam at EWQA. In order to stay on track with that, on week, I believe it's 5 and 6, and you're going to be able to see the outline, the course outline, if you go to the information page that Jen's. Okay, in order to keep it on track, on week 5 and 6, normally week 5 is the only week that goes about 90 minutes. There's a lot of information. We talk about ion exchange and how different water softeners work and that kind of thing. So that's week 5 when we mostly talk about cation, resin, and ion exchange. Week 6 tends to be short. They tend to even themselves out. So week 6 is usually only about 35 minutes. What we're going to do during week 5 and week 6 is combine the two. So and that keeps everything on track. So we are going to do that week, and we'll give you plenty of warning. We'll talk about it ahead of time, but that will be in order to keep the 15-week course actually taking only 14 weeks. We're going to combine week 5 and 6 together. Okay, so that particular day will be 2 hours. Everything else will be pretty close to an hour. Some of them are over in 45 minutes. Some of them an hour and 5 minutes, but we work really, really hard to keep them right at an hour or within that hour. So first thing that I need to tell you about this course is you got to read the books. Okay, this course, we've had a tremendous success rate on people that have taken the exam and come back, but the ones that have not passed have the one thing that they have come back and told us is that, wow, I really should have read those books. Okay, this is not a substitute for reading the material. The purpose of this course is to enhance what you find in the material. It's to explain it. It's to take what you read, the very academic stuff that you read in the book, and make it make sense, make it practical. So that's the first thing I'm going to suggest. And how you do that is up to you. I've had different people tell me they've had more success listening to the webinars than going back and reading the material, and I've had people tell me the other way, that they have read the material and then take the webinars and it makes sense. So we do have a ton of sample questions on the website too. After each lesson, after each class, you'll find a short sample test, and then we have larger tests that you can take for the general stuff, but to gauge where you're at, but you got to read the books. Webinars, we will upload the webinars. We try and do it within 48 hours. Actually, I usually try and do it that day, but if we are in another state or working with the company, doing consulting, that kind of thing, then we will, it may take a couple days to get that uploaded. If you really need it before then you can contact me and I can get you a direct link before we put it up online. What I'm going to do here, just to show you, Jen, this was a request of Jen. Jen just put it in the chat box. I don't know if those of you have a chat window open. A chat window is really important on these webinars, and an important component of what we do. So if you go up top, if you have not opened your chat window, I recommend you do so. Okay. If you scroll your mouse key up to the top, you're going to see where it says participants and chat, and you're going to have the opportunity to do that. I recommend you open your chat window up because there will be dialogue that goes on in that chat window. Now, I do record the chats also. When I upload them, you'll see the chats on the recording as well. But that's a great place to ask questions and to talk to people or to communicate. We always invite people on that have taken the course already to come back on again. These courses qualify for a continued education credit, 0.10, the 10th of a point. So even people that are certified, if they come back and they rewatch the courses, then they can submit that and receive sort of continued education points towards their WQA certification. So people will come back and review and sit in live. They like to sit in and watch the courses again, kind of doing it without having to worry about whether they're going to pass the test or not. I encourage conversation, and sometimes on those chat windows, you'll see somebody get on there and say, "Oh, you might see this again. This is important. This I wish I had studied this." So you may find some hints on there about things that you want to pay special attention to. I do ask, unless you want it to be private or specific, send your chats out to everyone because that's all that gets recorded. So you'll notice a box where it says send to. Make sure it says everyone in there. If you're trying to send it to one specific person, to Jen or myself, then just click on the person that you're trying to send that to. Okay, let me show you real quick. I'm going to share my desktop here, and I'm going to show you what it looks like on that web page if you have not been to it. If you have not received this this email, the email from Jen, then you're going to want to contact Jen, and she can everybody see my desktop there? Jen, can you see my desktop? Okay. Can you guys see my desktop? Yeah. Okay, good. I got. All right, good. Okay. Thank you. All right, so let's. What you're going to do is the link that Jen gave you will have this link on it. Now, there's no way to get to this link except through a direct link. Okay, so you notice I actually just pasted it directly into my into my desktop here, and let's go to that. Okay. And now you're going to go to the page. Now you will have to log in to the page. This is the information page here. You will have to be logged in to that page. So in order to get to this page, you have to be a member page. Okay. Now yours should take you directly to that page. All right. So now we're logged in here. Now this is where you will see that week's what the study. Okay. You'll see what we're going to talk about. There are different resources on here. You'll see I have the periodic chart of the elements on here. We will post periodically different things through. Here's your sample questions that you can take to go all the way through. But this is where you will find all of the pages. Let me show you the class that we are nearing the end of now. Let me show you what it looks like. Okay, so you can see this is. So you'll notice here you have all the webinars from that we have a current class that we started back in April 25th, and so you'll be able to click on any one of these and then see those. You'll be able to review those webinars, and then you can, of course, any of these, you'll be able to click on them and simply take the exam. So you'll be able to take the test. Okay. So you'll start the quiz, and there'll be questions, and you can just go through and answer questions, and it will give you your results at the end of that. Okay. So let's go unshare that, and all right, let's go back to the class. Okay. All right, so webinars, we will upload those. You'll be able to view them. As always, if you have any questions, let me know. Okay, check out LinkedIn and Facebook. We communicate quite a bit on those. So, you know, if Facebook especially, if you want to know what's going on with Moti-Vitality, we do have a new business Facebook page. We've been really ratcheting up our social media and our social networking. And with our new page, I just want to give a little plug there. Like us at Moti-Vitality Facebook. The link to that is facebook.com/Moti-Vitality without the hyphen. Or to get to the website, you have to have the hyphen on there. But so it's facebook.com/Moti-Vitality without the hyphen. And please like us on there, because once we get, and I'm just learning how to do this, but once you get 100 likes, and we've got 40-something, I think, as of now. Once we get 100 likes, then we are able to offer memberships and discounts and that kind of thing. So we will do that quite a bit for the people that we have on as liked Facebook members. So please check out Facebook. We upload a lot of the other tools and videos and things like that too. So like us at Moti-Vitality and Facebook. Okay, technical difficulties. I think that the technology that we use to do all of this stuff is incredible anyway. I think it's amazing that I can sit here in a hotel room in California and talk to people all over the country and do these classes. I love the technology. However, there are occasions where things happen, you know, where internet goes down, WebEx goes down, just decides to do that right at that particular time. Should that happen, then we will immediately, here's what I can tell you, unless I'm dead or crashed or something just horrible has happened, I will be here Wednesdays at 8:30 Eastern Standard Time. I generally try and get on about 15 minutes early. So I will be there, okay? So if you are having a hard time logging on, it could be WebEx, it could be my internet. I have major backup plans for internet. I have them wired in so many possible ways, and I usually, knowing that I have the course, I'll make sure that I have internet ahead of time. But we've had occasions, there's been occasions where the power went out at my home office, and I mean right before it was storming really bad, and the power went out. And if that happens, should that happen, or if there's a technical difficulty, then the first thing I will do is call Jen Smith, who is Moti-Vitality's general manager. She's the one who's been communicating with you guys, and sending you all that information. Call Jen Smith. Her phone number is up in the chat box right now. It's 248-762-4496. The reason I ask that you call her and not me is that I will be busy trying to log on and get on, okay? The worst we've ever had, the worst technical difficulty we've ever had has been where we had to send out a new invite to everybody because the invite, for whatever reason, with WebEx had expired. It didn't work. And so we had to send out a new invite. So call Jen or check your email. She will immediately shoot out a group email if we're having group problems, okay? So if you're having a hard time getting on, if there's something going on, check your email or call Jen. Please do not call me because, like I said, I'm going to be working to try and get on or get the problem fixed, okay? Call or email anytime with questions. All of you that joined this course, with the course included a Moti-Vitality membership. That goes way beyond just what you get from WQA here, okay? I and Jen both want to be a resource for you. And that goes beyond just this class. Please take the time to explore Moti-Vitality.com. We have hours and hours and hours of tools and audio and video and forms and things that we have created very specifically for the water treatment industry to help grow this industry. So please take advantage of your membership, but part of that membership also includes using Jen and I as resources. Okay, we have the opportunity to serve dealers and all over the country, and we have ideas and you know, have just different experiences and the way different people have done things, and we love the opportunity to offer a different perspective. So please give us a call or email us anytime, not only about the class, but about anything that you need to talk about. That is what we do for a living. Okay, and please give me feedback. Please give me feedback on on how I'm doing. You know, this is important. I really believe in the Water Quality Association. I love what the organization does for the industry. The strength in numbers, you know, I think we're going to need this organization and those like it as we move into the future in the water wars and that kind of thing. But it is, I think, really, really important that this class becomes as valuable as possible. Okay, I mean, obviously this is what I do for a living too, but I do not work for WQA, and the fact that they don't endorse, but they definitely support by giving the package pricing and by working with me to put the curriculum together. I mean, I communicate very, very, very closely with Water Quality Association, particularly Tanya Lubner over there, also Ann Parasiti, Daniel from the bookstore, Daniel LeBlanc. They're just awesome, awesome people. But I need feedback. I need to know if I'm doing something wrong, and I need to know if I'm doing something right so that I can make these better each time that I teach them. So please let me know how I'm doing, good or bad. I really appreciate that. And then just on a side note, let me again reiterate that I do not work for WQA. Okay, I am, Moti-Vitality is a for-profit company that specializes in hiring and training, sales and management, and water treatment professionals. That's important because sometimes my sense of humor is a little warped, or I may have an opinion or idea, and I'll try and clarify that does not come from WQA. That you know, when that happens, but I may have, my experience may have an idea or thought that may be a little different than what those at WQA may be. Okay, so that's important that you understand that while I support the organization and have been honored to receive their support, I do not work for them. Okay, and then the last thing is please participate. You know, honestly, for me, webinars are hard enough to do in the first place because we're sitting, you know, I mean, like I said, I'm sitting in a hotel room here. And I actually just talked to one of the guys who logged on right before I just got back from a run. And he's probably the one guy now. Everybody will know that I haven't even jumped in the shower. So it's hard enough doing these webinars with without being able to see somebody. So I like the participation. I mean, throw something up on the chat. Make a comment. Let me know that you're out there, that you're listening, because otherwise it gets the feeling sometimes like I'm just talking to the computer screen. And so I definitely appreciate your participation. All right. So any questions on the logistics? Any questions on how we get started there? Anything? Okay, please feel free to, if you have any problems or any questions, let us know. All right, so let's get started on actual, what we're doing here for the next several weeks, next couple months. So water. Yay, water! We're finally here. Let's talk about water. It's awesome stuff. We're all using it. Water's cool. Well, it doesn't have to be cool. It can be hot too. But yeah, I mean that is what we do, right? It's water. Basically, this is going to blow your mind. We use it for a bunch of stuff. That's it. Thanks, everybody. Okay, that's not it, actually. But we do use it for a bunch of stuff. So here's the official definition. This is what water is. It's the liquid which descends from the clouds in rain and which forms rivers, lakes, seas, etc. It consists of hydrogen, that's 11.188% by weight, and oxygen, which is 88.812% by weight, has a slightly blue color to it. It's very slightly compressible, and it has a maximum density at 39.2 degrees Fahrenheit or 4 degrees Celsius. Now, this is a relevant piece of information. So the maximum density thing, that one you're going to see again as we get in and talk about further methods of water treatment. Maximum, you'll notice that water freezes at 32 degrees Fahrenheit or 0 degrees Celsius, but its maximum density, that means that it's at its heaviest, it's at its densest at 39.2 degrees Fahrenheit. That becomes important when you're looking at technologies like filtration or when you're backwashing something. That means that the colder the water, then the more dense it is. That means that it takes less water to lift a bed up. You have to have less water pressure. The colder the water, the less water pressure to lift that bed up, because it will it lifts it's thicker, so it lifts stuff easier. Boils at 212 degrees Fahrenheit or 100 degrees Celsius. So that, and then we will talk quite a bit about water temperature too, because water temperature, that affects water treatment quite a bit too. Some things work better when the water's warmer. Gas is easier to dissipate, to get rid of, the warmer the water. Jen is making the point here that you may see the weights, the hydrogen and the oxygen weight consistency. You might see that again somewhere. So you may pay attention to that. So what to do with water? Well, you need to know what's in it first. And you need to know how we want to use it. And here's an example of that, okay? So you're, let's say you're using it for irrigation, all right? I mean, you're going to treat it differently if you're using it for irrigation than if you're using it for potable drinking water. So if you're just treating it to keep the iron and the rust stains from getting on the side of the house, then on your landscaping and everything, then you're going to treat it differently. The end result, it may be different at all. I mean, you can use water commercially, and it can still not be potable. So it really depends on what the end use is, what you want to use it for, and what's in it to begin with, on what you do with it. Pure water actually doesn't exist inside a lab, and this is kind of important too, because we'll talk about this when we get into the Code of Ethics, the WQA ethics, which is way back towards the end of the course. But we hear people out there in our industry talk about water purifiers, and well, the reverse osmosis, that's pure water. It's actually not, and there's a very strict definition of pure when you look at it, but pure water actually does not exist except in a lab, and that's because water is the universal solvent. It tries to dissolve pretty much everything it touches. Okay, so as soon as water touches the air, there's stuff in the air like dust and stuff like that in the air, so water's going to dissolve it. So it's going to be impossible to have pure water outside of a laboratory setting. So the term is very subjective. What constitutes harmful? Well, harmful depends on the nature and the amount of impurities and the tolerance permissible for each of those impurities, and also the end use of the water. Again, what is harmful? Are you talking harmful for drinking? Are you talking harmful for commercial equipment? Are you, if you have high TDS water and you're putting microchips in it, then it could potentially fry out those microchips because of the electrical current flowing through the total dissolved solids in there. On the other hand, you can drink that high TDS water. So it really depends on what the end use of the water is and on what constitutes harmful. The EPA was established way back in 1974. Well, it was passed in 1974. It was signed by Gerald Ford right after President Nixon resigned on December 16, 1974. And this established the Environmental Protection Agency, and it established the Safe Drinking Water Act as part of the Safe Drinking Water Act. So it was amended by President Reagan in 1986 and again by Bill Clinton in 1996. And there's been quite a bit of talk about amending it again in the last couple of years. But essentially, this is a 40-year-old law, okay? And that becomes relevant in what it's regulating and what it's treating. And we're not going to go into it a lot during these courses, but there is something called final barrier that is becoming more and more prevalent and important in the industry. And the reason final barrier is becoming so important in our industry is because the Safe Drinking Water Act is an antiquated bill. It's old. It does not cover the things that it needs to be covered. And what final barrier is, even though it sounds like it should be a Star Trek movie or something, final barrier, the Water Quality Association movie. I don't know. That was a horrible sci-fi impression or something. But I always think of that when it comes to final barrier. It just sounds cool to me. But what final barrier is it's treating the water at where you're using it. It's basically point of use. Okay, so what the municipal drinking water systems do is they treat it at the plant and all the way through the water lines. Okay, they're only required to treat certain things. So let's say you're a pharmaceutical company and you're looking for a new drug. You're trying to create a new drug. It's not illegal to dump. I mean, you've created a new molecule. Now, there's a whole list on EPA.gov. There's a whole list of what the minimum drinking water requirements are and the maximum contaminant levels are, and they list all of these chemicals and compounds and stuff that's in the water, minerals, all these things that you should or shouldn't have in the water, and what the maximum contaminant levels are, and the minimum drinking water requirements, and what their goals are, what they want it to be. They list all of that stuff, but it takes a long time and tons of studies and all of that stuff to figure out what should and should not be on that list and what the contaminant levels should be, and they determine on what is economically feasible to remove it from the water, on how much they can test it for. But it takes years to come up with a regulation on that stuff. So you're a pharmaceutical company and you're creating these molecules, these new molecules that they're not on any banned list anywhere. They're not banned, so they dump it in the water, no problem. It goes out there, and then they move on to their next experiment. And so things like pharmaceuticals, or just all these chemicals, these things that there are no regulations for, those things are not covered. And that's where final barrier comes in. What we're discovering is with the efficiency and the cost of membrane technology, now the improvements and also other technologies that are coming in play and that are making it easier we're finding it to be more effective and a lot easier to treat the water where we use it than at the municipality. I mean, we're using things like chlorine as a disinfectant, which is an excellent disinfectant. It works really, really well, but chlorines produce, byproducts like trihalomethanes, which are known carcinogens. So final barrier is, we're going to see more and more and more of that as we move into the future. It's a term that if you have not heard it already, I recommend you look into it. On my website, and I can send you a link to it if you're interested, there's an interview that we did on a podcast a couple years ago, one of the podcasts that we did when we were in Las Vegas with Richard Mest, who is the current president of WQA. And he talked quite a bit about final barrier and what its impacts would be and how it works. And it was an excellent interview, so I recommend you take a listen to that if you want to know more on that. But unfortunately, you're not going to, on this exam, see anything about the final barrier. The books were written, quite a while ago, several years ago, the WQA books, and a lot of the stuff in those books are antiquated. WQA they're revamping their entire certification program. Your certification will still be good, but that's one of the things that I try and do in this course is cover some of the more modern things that are relevant to our industry, and talk about them a little bit more, some of the things that you'll not get out of the books. So final barrier is something that you will absolutely see as the new certification programs are released in 2 or 3 years from WQA, but they don't mention it in the books anywhere now. Okay, what the Safe Drinking Water Act did is it established a definition for community public water systems, or CWSs. CWSs serve year-round residents. They include municipal systems, mobile home parks, apartment buildings, and condominiums with their own water source serving 25 or more residents. They're non-transit, non-community public water systems. So the NPN CWSs are entities having their own water supply, serving an average of at least 25 people who do not live at the location but who use the water for more than 6 months per year. Those include schools, churches, factories, and office buildings. The transit non-community public water systems, these are establishments having their own water supply, or an average of at least 25 people per day that use the water occasionally or for only short periods of time. So parks, motels, hotels, and restaurants. The Safe Drinking Water Act regulates approximately 220,000 public water systems across the country. They have strong suggestions of the way the water should be. They should no disease-producing organisms. The water should be colorless or clear. Go in here and make sure I'm muting everybody so we don't have background noise. By the way, I do keep everybody muted so we don't have the background noise. But if you need to talk to me, you can either chat or just right-click and unmute yourself, and we'll be able to hear you. Okay. Water should be good tasting, free from odors, and preferably cool. Now, these are strong suggestions, and the reason I know they're strong suggestions is I don't know if you've been to a little community public water system or something that's come from a community well. That's a public water supply, and boy, it's not colorless and clear, and it's not good tasting and free from odors. So it can definitely. These are suggestions. It should be non-corrosive, and it should be free of objectionable gases such as hydrogen sulfide and objectionable staining minerals such as iron and manganese. And it should be plentiful and low in cost. We will be talking about coliform bacteria again in the future. You're going to need to know about coliform. Coliform is important. Coliforms are guilt by association. Okay, they are strong indicators that there's fecal contamination, and that's because they cannot live outside of a warm-blooded animal. So coliforms themselves are not actual poop bacteria. Fecal bacteria, poop bacteria. I think poop bacteria should be the official term, mostly because it's way more fun to say. I mean, just those of you listening in, just say fecal bacteria and then say poop bacteria and see which one makes you giggle like you're in elementary school more. I just think poop bacteria is more fun. I think that should be the official term. But okay, whatever, call it whatever you want. Regardless, they're not actually those bacteria. They're just guilty because they hang out with the poop bacteria. Okay, they're around when they need to be. Okay, so here's what's interesting. Okay, you should never, ever, ever have fecal bacteria in your water supply. But the EPA says as long as you have no more than 5% of the samples, that means that 5 out of 100 can have poop bacteria in it. But you know, they recommend 0. That's the goal, is 0, none. But as long as you have 5 or no more than 5, then you're okay. And that brings us to you know, that kind of is an indication of the maximum contaminant level goal versus the maximum contaminant level requirements. And we'll talk more about those in just a few minutes. Just because water is potable doesn't make it good for every use. It is considered the universal solvent. That means it tries to dissolve pretty much everything it touches. Oceans are about 35,000 parts per million of total dissolved solids. And that's one of the reasons it's so hard to use reverse osmosis technology or any kind of a membrane technology to reduce those TDS. I know, being out here in California right now, we are there are signs everywhere, you know, talking about there's a huge political battle going on about the water shortages, and the state has restricted the amount of water they're allowed to use for irrigation. So driving through parts of California, you see these humongous farms that are just brown. They just little teeny tiny patches of crops growing on them, and they have signs, big billboards on these farms that says the state has cut off 65% of our water supply. You know, that we're only allowed to use you know, 35% of what we used in 2004, I think it was, and I mean, huge issue. But yet there's tons of ocean around. Why can't they use the ocean water? Well, that's because it's hard to treat that. There's 35,000 parts per million of total dissolved solids. Even with all the technology, that's pretty tough to do. The amount of total dissolved solids will vary depending on the water source. All right, so the hydrologic cycle, let's talk a little bit about this. All right, so basically, this comes from elementary school, right? We learned about this. Basically, what the hydrologic cycle does is the water starts off in the lakes and streams and oceans, and then it evaporates. The sun evaporates, and it goes up into the atmosphere, and it forms clouds, and then it forms with carbon dioxide and dust and all the stuff up in the atmosphere until it gets heavy enough that it falls back down to the earth in the form of precipitation, whether it's snow or sleet or rain. It falls back down to the ground. As it hits the surface, it starts to dissolve the stuff that is on the ground. So it's going to pick up surface contaminations, nitrates and coliform, you know, things that are on the surface there. But then it goes through as it seeps into the ground, it loses some of its surface contaminations, but then it picks up the minerals in the ground. So that's where you're going to pick up iron and manganese and calcium and arsenic and even fluoride and some of the natural minerals that we run into in the ground. So the hydrologic cycle actually it demonstrates some of what we use in the water treatment industry. So the evaporation is a process called distillation. I mean, we use distillation, and it's the same thing as evaporation. When you have water seeping down into the soil, that's filtration. It's basically filtration. You're removing those surface contaminants. We even have neutralizing. So those of you out on the East Coast that run into acid water or low pH water, that's basically when the water is acidic, when it comes down from the clouds and it's acidic because of the carbon dioxide levels, you're neutralizing, in most areas in the country, you're neutralizing that water by running it through calcium and magnesium, which brings the pH up high, back closer to neutral rather. That's basically the same thing that you're doing when you're running it through a calcite filter, those of you that are treating that with a neutralizer. So the hydrologic cycle is nature's water treatment. A little bit more about water. The less water in the air, the more temperature variations. It's interesting, even being out here, we are inland right now in the desert, and it got pretty cool last night. I went out for a run this morning. I left at 4 Pacific time, and it was pretty cold. It's about 60 degrees, but it's supposed to get up into triple digits today and tomorrow here where we are. So we're going to have about a 60-degree 50 or 60 degree temperature variation. I remember that one from when I was stationed out here in the service in the desert. It got that way. It would sometimes you would see an 80-degree difference between nighttime and daytime. And that's because it's very humid, or not very humid out here. You have very little humidity in the air in the desert, and so there's nothing to hold those temperatures stable. You know, those of you in the Midwest where it snows or where you see that, you know how in the wintertime, after a big snowstorm, you go out and you look at the stars and they are crystal clear. I mean, you can see it's just an incredibly beautiful night, but it's bitterly cold. And that's the reason you can see those stars so clearly is because there's no humidity in the air. But the reason it's bitterly cold is because there's no moisture in the atmosphere to hold that heat in. So it all just escapes until as soon as the sun goes down. Another thing that you may see this again is rainwater never gets completely soft ever. Even after raining for several hours, you're still going to have a little bit of hardness in there because all the dust in the atmosphere and everything that it picks up as it comes down through the air. Snow in the mountains has the lowest mineral content because there's less dust in the air up there. About 4,300 billion gallons of water fall every day in the continental U.S. About 70% evaporates immediatwater. And as water seeps into the ground, it loses some of the stuff it picked up from the air, but it gains other things. Groundwater, the age of groundwater can be determined by how much tritium is in it. So in case you're not going to necessarily see that on an exam anywhere again, but you can determine how old the stuff is by tritium. So in case if you're going to get this a lot, okay, you're in New York and somebody pulls up next to you in a flashing cab with all kinds of lights and they holler out the window, hey, what's the stuff that helps you determine how old groundwater is? You could say, it's tritium, and then they'll go, tritium, and then they'll win a lot of money and just drive away, and you'll go, hey, I think somebody in a cab just asked me. A good thing I knew what tritium was, but you can determine it. I mean, throw it out there, makes you feel smart if you ever just need to tell somebody. Groundwater is usually harder than surface water. Obviously, it's gone down and dissolved the calcium, magnesium. As the water seeps into the ground, it loses some of the stuff it picked up from the air, but it gains other things. Well is considered shallow if it's less than 25 feet. And in a lot of states or a lot of local municipalities, this is going to be, they won't allow shallow wells unless you have a special permit. So, I mean, that does affect it. But a well is considered shallow if it's less than 25 feet. And the temperature is going to be 2 to 3 degrees Fahrenheit above the annual mean temperature of the locality. And it decreases about 1 degree Fahrenheit for each 64 foot of depth. What that means is that if you've got an annual mean temperature, so the average temperature of an area is, say, 50 degrees, then the water is going to be roughly 52, 53 degrees, okay? Some of the disadvantages of groundwater, it has more hardness minerals in it, more iron and manganese, more hydrogen sulfide, and it costs more to pump it up. And the supply may fluctuate. It may vary. Because it may be, the underground water supplies may vary because of the amount of water that's the amount of rain or the amount of precipitation that's being used on a regular basis. And it may have things like nitrates in it too. Nitrates we're going to talk about nitrates in the future. Nitrates come from usually fertilizers and pesticides. And what they do is they create a really fun word to say. So methemoglobinemia, I'll give you a little hint, just so surface water, lakes, rivers, ponds, etc. That's what surface water is. Has a lower mineral content, but it's more likely to have contamination in it. So bacterial, algae, fish poop, and pollution and stuff like that. So it's more likely to have organic contamination. The sun does do a natural disinfection, or surface water natural disinfection. Actually, it's not only the sun does, the UV rays from the sun, but also bacteria and algae eat organic waste. So all those fish that died and all the stuff that's in there, bacteria and algae, they eat all that and help disinfect the water. Also, nature does it through something called ripples. Ripples are the little rapids that, as water runs over, if you look at a stream and it creates the little bumps in the water, those are ripples. And what that does, it causes oxidation, and it causes organic matter to settle. So it kind of it helps keep air in the water, and that oxidizes. That's a good thing. It helps disinfect it as well. And like I said, the UV rays of the sun will also disinfect the water. You may see a question sometime in the future that says, in what way does nature, or which of the following things act as natural disinfectants? You may see a question similar to that, something like that in the future. Okay. A cistern. You do see these still out there. They are around in places where groundwater is hard to come by or hard to find. And basically what these do is they collect. The gutter system runs directly into a big reservoir. Now, you will see, I think it's kind of cool, sometimes in these old houses, you'll go down in a basement and look around at it. You'll see where it looks like they, at some point in the past, have torn down a wall. Because you'll see like where they've had concrete, like a wall of concrete. They used to put these cisterns right down in the basement. And if you look and it looks like they've torn down a wall somewhere, look around on the walls, you'll probably see either a plugged pipe or a place where a pipe came out, and they've cemented over it or plugged it in some way where the water actually came down and filled up that cistern. Now the cisterns are a lot more modern. They tend to look more like this picture up that in the right-hand corner of this page. They do collect the rainwater, and that's where the water supply comes from. They'll tend to have a higher bacterial content and more color to them. Bacterial content because you're exposing it to the outside air. So you have to chlorinate it. You do have to, anytime you're exposing that water supply, you have to chlorinate it, which means you have to dechlorinate it, take chlorine back out. Okay, that is it, you guys. That's it for Class 1. I did want to mention one thing on that, on the web page there that we went to. If you're interested about what to study for and how the test is recorded and how it's scored, Dr. Lubner, Tanya Lubner from Water Quality Association, she's the Director of Education. We did an interview with her too on one of our conference calls, and that recording is on the page, on the main page too. Take a look at that. There's also a sample test result that shows the categories that you'll study for. That you can take a look at. And then I want to invite everybody on Thursday mornings at 8:30 a.m. We have sales or not necessarily all sales, we have water treatment professionals from all over the country join us. We usually have anywhere from 15 to 20 people on this call. We do not talk product and we don't talk company. What we do talk about is the water treatment industry and issues that we run into, and you'll find that on our website. If you go to upcoming seminars, you'll see it on the MV Pro conference call. Please join us. It's free. We'd love to have you on there and participate. It's just a half hour, and check it out and see what that's all about. Right now we're studying, just sort of working our way through Dale Carnegie's How to Win Friends and Influence People, and we always have just some amazing, phenomenal conversations, so I welcome you to that. Are there any questions or anything that we've missed or that you need to cover, before we end today's class?
Kelly, this is Jose from Purified Solutions. Good morning. How are you?
I'm doing great, Jose. How are you?
Very good, and hello to everybody. I have just a quick question with regards to the materials. The study material that for some of us who signed up with the package. Are we expecting that sometime by the mail, or is there like a digital format that we can use in the meantime?
That's a great question. Jose, we ordered them yesterday. Those of you that ordered the packages, those of you who ordered them before, they were already there. But Jose, we got yours ordered for you yesterday with an email to rush them to you. So they will be as soon as they are there. What I will do is I will call Daniel. Actually, if you'd like, you can call Daniel too, Daniel LeBlanc, but we will call him. We'll call Daniel tomorrow or after a while and make sure that that he's gotten those in the mail. But I suspect that they went in the mail yesterday, or if not yesterday, then this morning. So you should be receiving those. The rest of you who signed up for the packages to order all the materials, same thing. If you would like us to check and make sure that those are on their way, then we can follow up on that for you as well. In terms of another way for you to read them or get to them, it does help to have the books. So, you know what, I can maybe on this first class, I basically covered all the big stuff in this first webinar that you're going to need, that you'll need to know for the exams. But we'll make sure that those got in the mail to you. Any other questions for you guys? Those of you who signed up, there's some of you who paid for the exam and not the materials. Remember, that exam does not cover the cost of the proctor, but it does cover the cost of the exam, and we got you registered for that too. So if you paid for the exam already, wherever you decide to take it, that list has already been communicated and sent in to WQA and with payment. So anything else? Any other questions? Yeah, you will. Oh, good point, Jen. You will still need to sign up for the exam. You still, even though it's paid and you're registered and it's all there, you still need to let them know where you're going to be taking the test. Okay, so if you're taking it at EWQA, you still have to sign up for it and just let them know that you paid through us. But you should be set there. Good point, Jen. Thank you. And Paraceti has a list over there. All right. Any other comments or questions or thoughts? Thank you, everybody. I really appreciate it. If you need anything from us, please give us a call. And as always, honored to serve you. We will talk to you next Wednesday, if not before. So thanks, everybody. Have a great day.